Hello and welcome. My name is Dominik and I'll give you a short introduction to aiida-optimize. With aiida-optimize, you can perform optimization tasks on top of existing AIDA processes. First, let me answer an obvious question. Why should we use aiida-optimize instead of a more established library like, for example, scipy.optimize? And indeed, scipy-optimize is in fact a perfect tool for many cases. However, the limitation that it has is that the Python interpreter needs to keep running for the entire duration of your optimization. That can become very fragile, especially when a single function call might be a complex series of calculations or a complex AIDA workflow. Based on the capabilities provided by AIDA itself, aiida-optimize can overcome this problem. Let's jump right into the first example. Here I've defined a calc function exponential that takes two values x and c and computes the exponential of x plus the constant c. Now we want to find the roots of this exponential for a fixed constant c. The workhorse of aiida-optimize is the optimization workchain. Let me first import it. We can then create a builder. Using tab completion, we can find the possible inputs that can be given to this optimization workchain. First, we want to define the evaluate process. This is the objective function, in our case, the exponential. We also need to pass the inputs that remain constant during the optimization to this exponential function. We can do this by using the evaluate namespace. So here we pass the constant c as an input in this evaluate namespace. Then we also need an optimization engine. This determines which kind of optimization we are going to perform. In our case, we'll pick the bisection. By using the built-in documentation, we can figure out which additional inputs can be given to this optimization engine. Here we want to pass a lower and upper bound for the bisection. And we can pass these as an AIDA dictionary in the engine keyword args. Finally, we can run this builder. After a while, it is finished and we can inspect the result. There are two outputs to this optimization workchain. One giving the optimal process output, which in our case is not very interesting, it's just 0, and the optimal process UUID, which we can use to then load this optimal process. Using that, we can also inspect the inputs that led to the optimal result. The main takeaway from this short example is that there are two parts to running an optimization. An optimization workchain, which is always the same, and an optimization engine that differs depending on exactly which kind of optimization you want to run. One assumption we've made in this simple example is that there's only a single input that we need to vary in our optimization. Let's look at a more complicated example to see what we can do when this is not the case. Here we have defined a workchain that takes three inputs x, y, and z. However, each of these inputs is given in a different way. X is given just as a simple input, y is nested in a namespace, and z is given as an attribute of a dictionary. To make this workchain compatible with aiida-optimize, we need to pass it through a wrapper workchain called add-inputs workchain. Again, we create a builder for this workchain. We pass the potential workchain itself in the sub-process input. In the added input keys, we list the names of the inputs to be used in the optimization. For x, we can just give the name itself. For y, which is nested inside a namespace, we can pass namespace.y. For z, which is nested inside a dictionary, we can pass set:value. Now the added input values is just a single list or a single input that contains all the values that we want to optimize. Now we can run this add inputs workchain. Knowing how to convert this complicated workchain into a workchain that takes a single input to be optimized, we can repeat the process from the previous example. First, we get the optimization workchain builder, and we pass the evaluate process. Note that this is now the add inputs workchain. In the evaluate namespace, we again pass all the inputs that remain constant for all function calls. These are the added input keys and again the sub process. An important detail here is that we need to convert the potential workchain class into a string explicitly. Previously this was done automatically, but because of the added level of indirection, this is no longer possible. In this example, we use the Nelder-Mead optimization engine. This is capable of optimizing a problem in multiple dimensions. Again, we use the built-in documentation to figure out which keyword arguments can be passed to the Nelder-Mead optimization. The starting point of the optimization is a simplex, which consists of 4 three-dimensional vertices. Because the input name we want to optimize is no longer the default x, we now need to specify it explicitly. The same is true for the name of the output. And finally, we reduce the tolerances to make this all run a little bit quicker. Again, we can now run our builder. This will take a while. And finally, we can again inspect the output. With these 2 examples, I hope to have given you a good feeling for what you can do with aiida-optimize. However, I should also mention its drawbacks. First, there is quite a bit of overhead when calling a single function through aiida-optimize. This means that if your function call is supposed to run in the order of milliseconds to seconds, you are better off using, for example, SciPy optimize instead. If your function calls are supposed to run for multiple minutes, maybe hours or longer, then aiida-optimize is the right tool for you. And also the number of optimization engines currently implemented in aiida-optimize is quite limited. We have bisection, Nelder-Mead, and the parameter sweep. Let me conclude by mentioning where you can find more information on aiida-optimize. On the documentation website, you can find a short tutorial and a reference for the different parts of aiida-optimize. On the GitHub page, you can make feature requests, or we can collaborate on implementing new features. You can ask a question either on the GitHub page or by sending an email to me directly. Thank you for your attention and happy computing.